Hi friends, welcome back to another episode where I write a ray tracer from scratch based on the book The Ray Tracer Challenge by James Buck in a language, Rust, which I am learning while doing this ray tracer. Before starting with this ray tracer project, I've never written Rust before and I'm using this project to learn the language as well. You can find all the needed information in the comments below, where is a link to the GitHub repository as well as to this book if you are interested in getting one of those yourself. Okay, so what are we going to do this time? What have we done last time, we should ask first. So let's take a look at this. The last time we implemented a YAML reader, which is capable of reading, let me quickly close this console there, which is capable of reading a file formatted like this, which is a YAML file where we define our world, our scene, which should be rendered. So we have lights here, we have different body types, like for example a plane, which is our floor here. We can have comments, as you can see here as well, to structure it a little bit more precise and readable. And we are defining our different materials here, or spheres and stuff like that, which is another body type. And then in the end, we are defining camera objects there. We can actually have multiple cameras which look from different angles into the world or differently positioned. And we are using this to render our scene. So if I'm going ahead and rendering this scene, I guess I could use this one. Yeah, we are calling our render YAML binary. We are here providing our YAML file there, which you are seeing here currently. And then we are opening up the second scene, just all in one command. Let me quickly build this and render this. And then, yeah, we can see. So now, as you can see, both perspectives are rendered and ray traced. And now the first one is open. Let me bring it into view. So this is our current scene we are working on. You have this floor, we have these three spheres, which are defined in the YAML. So this is the state we currently have. And now we want to add something new. We want to be able to add patterns. So we do not want let me open second camera there. Let me open up the picture again. We don't want only simple static colors here, but we want to be able to apply a pattern. Essentially, if we want to, a three-dimensional pattern later on maybe, to this sphere. And first of all, or to essentially everything in this scene if we want to, which is simply an overlay which decides which point on this thing has which color. We are not doing full-fledged texturing or something like this there yet. Maybe we will do this later on, but not yet. But we want to simply apply a pattern, a stencil onto this objects here. Like, for example, let me see, striped pattern, something like, let's see, yeah, something like this, for example. So we simply want to apply something like this, and actually I've chosen this because the first one we are going to implement is a striping pattern, like exactly like this one, and we want to be able to apply this to any object of the scene. And maybe later on we will maybe later on implement something like this, or any other kind of pattern, like a circular pattern, or maybe a checkerboard pattern. You may have seen this in different other 3D renderers where you have floors and stuff like that, which usually have by default a checkerboard pattern to see that they haven't been textured yet. So yeah, we are actually in the process, or want to implement exactly that. So yeah, so I guess we are starting, as we are always doing, by creating a new file. So let's call it pattern.rs, I guess, and it's empty yet. And we need to include it, of course, in our library. So pubmod pattern to have it being loaded so that we can fill it with life. And now let's think about those patterns. Actually, I already know there will be more than one. I don't only want to implement a striped pattern, but I want to implement others as well. Like I've said, a checkerboard pattern, for example, a radiant pattern, and maybe others as well. So I guess we are using the same technique which we already had used for bodies, for example, where we have this static dispatch pattern going on, where we have a trait that implements all the needed things that a body object needs to implement, and then we have an enumeration, which is our kind of base type, which implements this as well, and then simply dispatches statically using the matching here to the correct implementation, so that we don't need a vtable or stuff like that, but we have compile time dispatching calculation actually, because we are going to know all of the different patterns we are going to implement or to have available, and we don't need this to be dynamic. So we can use this static dispatching system here as well. So I guess we are starting with our trait, and I'm going to name the trait stencil, I guess, because yeah, a stencil is something that you apply to this, so that we can make this pattern structure out of. So we are applying it actually, a stencil. Yeah, I guess. Maybe I will rename it later. No idea. So now we have this trait stencil, and this is actually what all our patterns need to implement. So what do all our patterns need to implement? Patterns are, as we can see here, based on the screen coordinates. So in our case here, we are only basing it on the x coordinate. You can easily see that the y does not have any, or doesn't change anything there, but the x. If we have a more complex thing like this one, for example, there's of course an x and y which influence somehow the pattern there. But for now, I guess it is essential to note that we need the coordinate there. So I guess we will simply calculate a color based on the intersection coordinate. So let's for now create a function here. Let's call it color@. And it takes, yeah, a position, I guess, which is a tuple. And it will output a color. So no idea if this works out yet, but let's see. So yeah, so now we have this stencil trait. If we need later on more, we can easily add it. But this is essentially the basic work we need to do. We need to have the new color based on our stencil for every intersecting point. For every point we want to calculate lighting and stuff for, we need this color, which is then calculated by the stencil or pattern later on. Okay, so now that we have that, let's create our enumeration here, which we will call pattern. And it will be public as well, because we want to use it from the outside, of course. And for now it is empty because we need something else as well, because we need our first pattern there. And yeah, I guess I call it striped. And the stripe pattern, what does the stripe pattern need? It needs two colors essentially, the first and the second. So it's simply flipping between those colors, and yeah, I guess we need those, and yeah, so let's have them here. Let's just have I guess color A, which would be a color, and color B, which would be a color. Yeah, I guess so. Now we can have our first pattern here, which is our first typed pattern here, which is of course named the same. And it's, yeah, this needs to be public as well then, because we are using it here. And now we need a way to create our patterns. So let's, I guess, implement from striped for pattern, yes. And This is quite easily done, just some busy work here, and we are returning a new pattern of type striped, which is actually then the input here. So now we can easily use something like pattern from and put a striped struct in there, and we are getting this pattern type. So now that we have done this, I guess it's time to think about implementing the rest of this. So let's see. We need to, where do we, yeah, I guess we need to implement first and foremost the stripe pattern here. So let's implement stencil for striped. Let's see. So what would this be? How could this actually be implemented? If we wanted to implement something like this pattern, we would as I've said, we would to flip between those different two colors in a certain interval. So yeah, let's maybe do this. We obviously only need the X position here. So I guess we can extract X first. So let's take it out of the position, and then now we need to, how are we actually going to do this, flip between those? We could do something like, let's see, do we want this spacing to be variable? Do we want to be able to say how long each of those intersections are, so that we can actually make the pattern bigger or smaller? Or are we doing this by implementing this in a default way and later on applying a transformation on it as well? I guess we will do this with a transformation later on. I'm not 100% sure what the book says about this, because I haven't finished reading this chapter yet, because I just wanted to get going and implement this. But yeah, if the book doesn't do it, I guess we are going to do it, or at least I'm going to try. Or I will later on introduce sizing parameters there. So for now, let's assume we have our basic pattern as we have with our basic bodies, which are always in their unique position in the system, which are always in the origin of our coordinate system and have a basic size and stuff like that. And we are simply transforming those with matrices. I assume we could do the same thing with patterns. So let's see. When we have this one, we could simply do something like if our x value, if we floor our x value, so we are always going to the next full integer, and then we are calculating a modulo by 2. And if this is 0, then essentially we should already have our possibility of, okay, could not, yeah, of course, because this is a floating point. So I guess we are making an I size of this. And then we should be able to simply return self color A here and self color B here. And what's now happening there? Found self. Oh yeah, as always, when I'm writing code for work in another language for some time, I'm forgetting to add the self there. So of course we need to add it here in our trait as well, so that we have access to our struct there. So perfect. Yeah, so actually this might already be everything we need to do. So because we are flooring it, so we are always taking the space between between always those full integers, so always a length of 1. And if we are then calculating modulo 2 of it, we should actually be able to have this striped interval there. So I guess, I hope, let's see. Let's see if this is actually how this will work out. So now that we have implemented this, we of course need to implement the static dispatching here. So we have this pattern here. So let's implement stencil for pattern. Yeah. Implement stencil for pattern. And now we need to match. Now we need to match self here. And if self is a pattern, why am I doing this in? What am I doing here? So if it's a pattern, striped ref striped, something like this, then we want striped dot color at with a position to be called. So as we don't have another variant of this pattern there is only one of those matches, and we only need to dispatch to one of those functions. And this should actually already be it. However, we can't currently easily instantiate our striped patterns, so maybe we want to implement, I guess, impl default for striped, as we have by now learned that this is a good idea. And so we are, I didn't want it to make this smaller, I wanted to implement this one. So yeah, let's start, for example, with black and white by default. So let's use this black default color we have. Yeah, we have it. And let's color. Do I have a white default color? No, I don't have. So maybe we should just add this one for the color. So now we have a white default as well. We need, of course, to adapt those values then. Otherwise, we would have named it white and it would be black. That would be not good. So let's see. Now we should have, yeah, a white default color. So now we have a default implementation of striped. And what we are now going to do is the same thing we did before with, where did we do it? The camera, for example, and a lot of other things I've refactored in the meantime, where we where is it? No, it's not. Is it? It's not camera. It's not. No, not camera. Camera. Not like. Where was it? Material, I think. Yeah, material, for example, has this default implementation, which simply creates a kind of an empty material, and then I can call those with something functions if I want to override some of those properties. And I actually like this pattern until now. Maybe I will not like it in the future and will refactor it, but until now I like it. So I guess I'm doing the same thing here with our pattern. So let's implement it. Let's see. We would need then fn. Do we want to be able to differentiate and instantiate it with different colors so that we only override one of those? I guess this doesn't make a lot of sense. So I guess we only want with colors then, because either you're using the default or you are overriding both of the striped colors, I guess. So color A is color there, and color B is, come on, a color as well, and returned is a self. And yeah, and we are taking actually a self, but not a reference to self, but the ownership of self as input. So what we can now do is we can say self dot color A equals color A, and self.color B equals color B. And we are giving back self again. And yeah, we of course need to have it mutable. We want a mutable self and taking ownership of it and then returning the changed self and giving the ownership back to the caller, essentially. Yeah, okay, that sounds and looks reasonable. So I guess, even though if this is everything we need to do to implement our first pattern, this would be quite nice. We of course need to use it, but yeah, let's see. I guess this is already our first pattern. So let's see. Okay, so now we need to somehow use this, and I'm actually thinking, yeah, it needs to be incorporated into a material, of course, because our lightning calculation needs this information now. So I guess our material here, in our case, our Phong material, will now get a new property, or are we? Essentially, the pattern is determining the color now, and even though it might change as it is based on the position, there could be some sort of solid stencil or solid pattern, which would then only take a single color, and we would only have this one property here, which is then stencil or pattern or whatever. I actually like the word stencil better than pattern, but that's not important now. This would mean that we don't have both, because once we have some sort of pattern, this color is not applied in any way anymore. So maybe we want to replace this completely. Not sure. Yeah, but maybe for now, let's maybe for now integrate it besides the color and decide which one we use, and we will then refactor this maybe later once we are sure everything works like we wanted it to. So we have now another pattern here, or no, better said, we have option patterns. So there's a T missing. And it of course is not, I need to import it because the pattern might not be there. Copy trait. Yeah, of course, our pattern needs to implement copy and clone and debug and partial equality in a second, but we can derive those, or we can actually quickly have those here. Let's see, where's our pattern? Let's add them. So our basic pattern needs those, and then of course our, where is it? Our struct needs those as well. They should be derivable. So yeah, okay. So we have this now, but let's see. Phong now. Yeah, of course we need to give it a new default pattern now, which would be none by default, I guess. And this here would be the same, I guess. Yeah. So let's for now add a pattern none here as well. Or do we want to have this constructor here and want to force the specification of a pattern? I'm not even 100% sure that we need this new function anymore. Let me take a look. Are we using it anymore anywhere? So we are using it here. Like, okay, but we can actually we could actually create the exact same thing using our default and the width functions. So I'm not 100% sure. Our sphere here does the same. It's in a test as well. And our YAML thingy does it. Okay, so we are only using this for specification in tests because it is a little bit more concise. Yeah. Maybe I will remove this in the future, but not now. Okay, let's add a fix me. Fix me maybe not needed anymore. Could be removed and replaced by builder functions. Come on. As we have already done with other places. We could use all of those, and yeah, but not now. So we now have this implementation here, and we have this default here. And by default, we are creating exactly a none pattern. So let's see. Oh, we need to, yeah, we need to, of course, now incorporate this into our fuzzy equality comparison as well. So self.pattern fuzzy equality other.pattern. And yeah, of course, our pattern does not implement fuzzy equality. So let's quickly do this, I guess. So first, I guess our base pattern, our implementation here needs to do this. So let's impl fuzzy equality striped for striped. So to compare it with itself. And yeah, we need to import this, and then we need to implement it. So now we have this self, and this is simply a matter of color A, fuzzy equals other color B, and self color B, fuzzy equals other color B. There we go. And now we need to implement this for the pattern itself, I guess. So impl fuzzy equality one pattern with another one. Yeah. And let's implement this, and now we need to, how did we do this, for example, with body, to have, to only compare the same types, I guess, with a match, but yeah, there. Ah, so yeah, we matched both. So they always needed to be the same type. Yeah, okay, this makes absolute sense. So we are matching a tuple here of self and other. And let's see. So if it is a pattern striped, which would then, we could then reference here as striped. Yes, and the other one is a pattern striped as well. At the moment, there is no chance of having something else, actually, but it might be possible in the future, or it will most likely be possible in the future. So then if this is the case, then we want to do striped fuzzy equality with other. And otherwise, in every other case, it's false, even though I guess this is not possible at the moment, but okay, seems to work out. So because if we have, for example, a striped and something else, a checkerboard or whatever pattern, then this will be false. We don't even need to compare it anymore, so any further. So now we have implemented this. This one should be, let's not. No method named fuzzy equality for enum option in the oh, yes. So, oh, that's right. How do we compare options with each other? Because pattern now is an option. Could I write a generic fuzzy equality for options? I think that should be possible, as we have done with other things like string, for example, and stuff. So let's see. Implement fuzzy equality. Of what with what? Okay, so I want to have some sort of option of an arbitrary type t. And I want to compare this one with option of the same type t. Yeah, then I of course need to have this here because, yeah. So can I, what have I missed here? Oh, there's a for missing. So implement missing members. Trade bound T clone is what? The trade bound T clone is not satisfied. Required because of the requirements on the impl of clone. For option T. Okay, required by bound and FuzzyEq. Okay, I can only do. Is this where T implements clone? I guess fuzzy equality only works for clonable types then? Okay. So yeah, now we need to do something. We need to match self and other. We are essentially using the same technique as before, and we are having if we have some other, no, what would it be? Say some, let's call it option then, and we have some other, then we are mapping this to option dot FuzzyEq other, I guess. And what would be if we have none and none? This would be true because those are the same as well. And if we have anything else, we are having false. Now let's see. No method fuzzy equality for reference T. Yeah, that's right. Oh, we can specify that T needs to implement fuzzy equality with itself. Okay. Wouldn't have guessed that this. Who would have worked this nice? We actually have a run. We seem to have a run here. So nice. Okay, so now this works as well. And we can have this fuzzy equality there. This is nice. Okay, so let's see. Now that we have this within our Fonglight illumination, we can actually use it. And let's take a look at our illumination here. Let's take a look at what we are actually doing here. As I've said, the pattern will essentially replace our color if it is set. So we are using our color. Where are we using? Ambient, specular light, effective color. There it is. Self color. We are using self color there. So this is the color defined, but we only want to use this if there is no pattern. So let's see. Let's get a color here and let's put self color in it. And let's make it mutable, I guess, because we maybe want to change it. So now if let some pattern equals self pattern. So if we have a pattern, then we want to set the color to, come on. We want to set our color to pattern.colorAt. And how is the position called here? Position as well. So yeah, so we want colorAt position. So yeah, and we have that. And then we are using this here for our further lighting calculation. So either we are using the color from our material now, if we don't have a pattern, but if we have a pattern, we want to apply this one. Maybe we could think about somehow multiplying those colors here, so we are actually combining them. Like we could have a transparent color, but I guess our colors can't be transparent yet. No, they don't have a transparency component. Maybe we could change something like this so that we can apply a transparent pattern, something like make this stripe darker than the one before, but use the overall base color of the material or something like this. Yeah, maybe. Maybe not. I don't yet know. So, but for now we are, where were we? For now we are simply using the pattern color at the defined position. Yeah, if we are if we have one. And if we don't have one, we should use the color itself. So if I've done everything correctly, this should actually still render. So let's see. And it should produce exactly the same reason. What? Unreachable pattern. Okay, we need to take a look at those. There is something we are not using yet, or not anymore. So let's see. Okay, so yeah, it's exactly producing the same result, which is nice. It still compiles and produces the same result. So let's quickly take a look at those warnings. Okay, so we have a branch there, which actually cannot be this one of course cannot be reached because we only have a stripe pattern there. So there can only be a match of stripe pattern against the stripe pattern because this enumeration only has one type. So we can remove this for now. We need to, of course, add it once we have more than one pattern type, but that shouldn't be a problem. And then we have this with colors. Okay, why is this with colors? There shouldn't be something with, oh, because I didn't make it public. So yes, okay, so nice one. Thanks Rust for catching this. Okay, so yeah, let's yeah, I guess we will assume that we can compile it still. So there shouldn't be anything wrong with it. Yeah, so actually we now have implemented our first pattern. So how are we going to use it? I guess I could now implement, or I would want to extend the YAML parser to be able to parse a pattern. But as I'm not 100% sure yet at how I'm going to incorporate this, as I've said, I might replace the color altogether. I guess I'm not doing that, but what we could actually do to easily check if this is working, we could use this. We have verified that this new is only used in unit tests, so we don't care about that. But we could actually, during this default thingy here, put the pattern in here so that every implementation currently using it, like for example our YAML renderer, would use this pattern. So maybe let's do this pattern from, what would it be, striped default? I guess. Then we should have a black and white. No, I don't want to make this smaller. I simply wanted to import this and import striped as well. And now we should actually, yeah, we should actually have a striped black and white pattern everywhere. So let's check if it's really that simple to hard code it in. And let's check for pattern calculation works at all, or if everything is going to explode now. Let's see. This is looking awesome. Ladies and gentlemen, we have a pattern implementation. Yeah, so as you can see, we have implemented striping. Not 100% correct yet, but actually this is as I've expected it. Let's take a look at the other camera perspective as well. Main camera. Yeah, that looks quite awesome as well. So as you can see now, this actually works. There is a patterning effect throughout the scene, but as you can see, it is based on the world. So it is based on, I really like this. I never had the idea of ray tracing a black and white scene. I've never even thought about using only black and white colors in it. And this is, that's quite amazing. I really like that. Okay, sorry, I'm diverging, but I like it. The problem here is that we are now applying this based on the point given by, let me can I somehow, no, I cannot show both easily. We are calculating those pattern in world space. So it is the same for the whole world. As you can see here, our floor is patterned exactly in the same way that our sphere is, or this sphere is. or this sphere is. And this one is standing completely on one of the patterns and this one completely inside of one of the others. And I actually like it that it's like that, but it's complete randomly that this happened there like this, but it looks quite neat. Because everything uses the same pattern space, and we would need to apply the transformations of our objects which are placed in the world to the pattern calculation as well. So yeah, I guess this is what happens next in the book. Let me quickly check. As I've said, I haven't read the chapter. I've only started the first 2 pages and was already like, okay, I think I know how to do this. Let's do it. So yeah, and then they are actually, yeah, this is exactly, they are implementing the transformations as well. So yeah, so this is the next step, the next logical step, which I was thinking about as well. But first, I guess we need to integrate this somehow better to have it in a more usable way. And of course, I want to write, as I've done with everything else, unit tests for this. But as my time for today, for this session here, is a little bit limited currently, I guess I will stop here. I will, of course, add the unit tests later on, and I will show you this, or will commit this to Git. Let me, can I at least have both? Yeah, something like this. I will leave it at this, and I will add tests later. I will commit this, of course, and you will be able to take a look at this. And I think this is a nice break, and we were really fast. I wouldn't have expected it to work out this well and this quickly. So I really much enjoyed that. But it fits my timetable for today perfectly. Yeah, and I guess then I will see you in the next one, where we will then fix up those transformation issues there, and then go ahead and implement more and different patterns. Now that we have the basics of it ready, we can easily do this. So yeah, I'm already looking forward to seeing you in the next session. As I've said in the beginning, there is everything you need to follow along in the this linked in the description below. A link to the GitHub, for example, where you can find all the source code, as well as a link to the book, should you be interested in using it to do something like this yourself. I really much enjoyed it, and if you want to be informed once the next session is up, please subscribe and hit the bell, and please give this video a thumbs up if you liked it, because it helps me really with the YouTube algorithm to be found by more people who might be interested in this as well. So yeah, I think see you the next time, and goodbye.